Hi, this is Mrs. Davis. This is AP Computer Science. This is lesson 7.3. This is the third video, and we're going to just start talking about something called runtimes. So how do we choose what algorithm to use when we're trying to solve the same problem? How do we know? And so we call that the runtime, which measures how fast they run, which is really important if you're running a whole bunch of data. So if you're talking about searching, it depends on the data that you have. So binary search is much faster than linear search in general, especially on large data sets, but it can only be used on sorted data. Now, here's how computer scientists think when they're trying to figure out runtimes. They think about the worst case behavior. While searching, the worst case is usually that you can't find the item. So how long does it tell you to see that that item is not in there? And now linear search, it would be you have to go through the whole array or the whole list. But in the binary search, if it's not there, you can see it cuts it down. So it eliminates half the data set each step. So they can measure informal runtime by counting the number of steps in, we should add, in the worst case scenario or behavior. So like not finding it is how they judge it. So if it's worse, the worst it could be is this. So here's how you, here's some examples, and then I'll show you how we can figure that out. So if you look, if you have n is the number of items in the list. Okay, so if you have 2, the linear search is going to look twice, and the binary search is going to do two comparisons. Okay, that makes sense. There's only 2, it's going to look 1, 2, and it's still going to take binary search 2. So they'll be the same with 2 items. Now, when you get 4, the linear search will have to look, worst case scenario, it's going to look at 0, 1, 2, and 3 index, and then realize it's not there. So it would take 4. A binary starts to get a little better with 4 items. It only has to check 3 times. If you have 8 items, it's going to take 8 times. Of course, this is always going to be the same for the linear, right? The worst case scenario. But if you have 8 items, a binary search will take you half as many, 4. So we're starting to really look a lot better. 16 for the linear will be 16, but the binary only takes 5, sorry. And look at this. If you jump from 16 to 100, all it did was make your binary search do 2 more than 16. You'll get it in 7 times. So, I mean, that's huge. Okay, that's huge difference. So, let's skip 1 because I want to show you how to do that. That's asking, you got to watch what they're asking for in these questions. How many times will the loop in the binary search run for an array like this with a binary search ARR 55? So, they want the exact number of times. So we'll do that one in a minute. Now 2 says if you had an ordered array of size 500, what's the maximum number of iterations, so worst case behavior, it's not found, required to find an element with a binary search. So it's called find it, but it really means if you're doing the worst case, or the maximum number, you're going to have to look through every single one of them. All right, so here's how you calculate how to do that. So I'm going to start out with our table up there, and I'm going to show you, since it's binary, we go up by binary numbers. So we have, you know what 2 to the 0 is, and 2 to the 1, and 2 to the 2, and 2 to the 4, and 2 to the 6, is 1, 2, 4, 8, 16, and then it would do 32, 64, 128, Okay, so that's how the binary system would work. And so we use this knowledge to tell us what the worst case scenario would be. So let's do 4 items. If I have 4 items and I'm doing a binary search, we know it's supposed to take us 3 times. So let's see how they get that number. And what you do is you start with the binary numbers till it gets to the number or past it. So I'm trying to get to 4, and 4 happens to be 1. So I'm going to go 1, 2, 4. And I'm stopping there because it hit the number I wanted. or went past it, but in this case, I hit it. So it took 3 times. Now the next example, and so that was what this said, 3 times. The next example is 8. So we have 8. We'll start at 1, 2, 4, 8. So we hit it right on 8 this time. So you can see it took us 1, 2, 3, 4. So we have 4 times. That's right, that we're talking about how many times we had to check. So how many iterations did I have to go through the loop? If you see 16, we would have to go 1, 2, 4, 8, 16. 16 hits right on it. So I need an example where it doesn't hit right on it, and I will in a second. So that's 1, 2, 3, 4, 5. So that was for your 5 times for 16. Now watch how why 100 is only 7. Okay, this is a great example. So we have 100. So if I have to get to 100, I do 1, 2, 4, 8, 16, 32, 64, and I'm already at 128 over here. All right, so 100 falls in between here. And so you use the 1 before it. So you count like you stop here. So you count 1, 2, 3, 4, 5, 6, 7. It took me 7. So if it falls right on it, you count that one. If it falls after it, you don't count the 1 after it, you count the 1 before it. So it would be 7. All right, so do you see why? It's because this is multiplying, exponentially there. 2 to the 3rd, 2 to the 4th, 2 to the 5th. So let's say we wanted, 350. How many, if I have 350 items, we would say 1, 2, 4, 8, 16, 32, 64, 128, 256, and then 256 would be 512. So 350 is going to fall in there, so I'm just going to count these before it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So to get 350, if it had, not get 350, but if it had 350 elements, it would take me 9 times to go through the whole thing and not find it. So I hope you understand that. That is, again, worst case scenario. Now, I want to, I want to do this problem right here where we have this guy. So I'm going to rewrite it down on the bottom of my paper here. This is just the binary search typed up nicely. So it's just like what you already wrote in your notes. And this is, it'd be fun to put this, if you go ahead and put this in you'll have your binary search, and then you could create a main method and do some testing to see how many it takes. All right, so you can even check if we're doing what we're doing right now. So, all right, here was that example. It said that we had an integer array, and it was preloaded with 2, 10, 23, 31, 55, and 86. And it called this binary search with an ARR using the name, we're going to use ARR for the array, and it wants to find 55. So it's calling that binary search. Okay, so I'm going to try to do this so that you don't have to write out the table. So you may figure out your own way, and this is just kind of my chicken scratch to do it, but I feel like I should share it with you, and it might help you. So first, you have to put your indexes up here because you're going to be using those for the majority. You just check where you are. You just check your index once you find the middle one. All right, so the first thing I'm going to do is think my low and high. So here's my low and here's my high, and I like put arrows on them. So I'm looking at 5, and you can even do like chicken scratch over here. 5 divided by 2 is 2. So my first guess would be at index 2. So there's my first guess. I'm going to put a 1. Okay, I probably shouldn't even put an arrow. I should just put a 1. And I'm going to put it up here. That was my first guess. Now, if you look at what 2 holds, it holds 23. Now, 55 is greater than 23, so I know I'm in this section now. And so I move up my my low to the one right past, because I already know it's not 2, right? I checked it. So I'm going to go 1 past. So my low is now index 3 and my high stays at index 5. So then I'm going to add 3 plus 5. So 3 plus 5 divided by 2 is 4. So we check 4. So this is 2. I'm looking at 4. And 4 is the right answer. When it looks at it, it goes, okay, it's 55. So it took me 2 times to do that. All right? So that's kind of how I'm showing you using your arrow. Now, I have like, let's see. I was just trying to see if we had an array in your homework. Let's see if I can pull that. Well, I'll stop the video there, and then let's take a look at a couple problems from your homework. It might help you out. This is not the easiest topic, so